that is a big takeaway. Okay, at this point, I usually like to ask a little bit about you, but since this is a virtual meeting, I won't ask for like a raise of hands. But if you are an undergraduate student, a graduate student, postdoc, faculty, or anywhere else in your career, I hope you will get something out of this talk, no matter which stage of your career you're at. Okay, so I'm going to start with some statistics. So I'm going to talk about the number of physics degree holders. I'll then go into the career paths of different degree holders and where they tend to go, where they tend to end up. I will then give you an overview of the outlook of academic careers and then of industry careers. Then we will go over what you can start doing to prepare. So what students and early career scientists can do to prepare for their careers now. And then also how faculty and mentors can help. And then we'll end with questions. Okay, so going right into the data, I know we all love data. So just looking at how many physics PhDs are there, the number of physics PhDs granted in the US has almost doubled over the last 2 decades, which is really exciting. So if you look here at 2018, we have more than 1,800 physics PhDs being granted every year. If we look specifically at 2015 to 2016, that year graduates, 1 year after the physics PhD, 1 year after getting their degree, of the 1,850 physics doctorates, about 13% left the US, and so 1,600 remained in the US. So how I like to think of that is that about 1,600 physics PhDs go into the job market every year. In addition to that, we also have a lot of folks getting physics masters. So about 700 new physics master's holders are also getting their degrees every year. And of these, we have, so of these 700, about 300 or more look for jobs or continue their employment. The rest continue to get higher education. Okay, what about physics bachelors? The number of physics bachelors are also rapidly increasing every year, which is great. By the way, all of my, most of the statistics in my slides, most of the data I show is from AIP.org. So you can actually go check out this data at AIP.org/statistics anytime you want. There's a lot of good data there that is fun to look at. So physics bachelors, there are more than 8,500 physics bachelor's degrees being awarded annually. And of these, about half goes straight into the workforce as well. So putting all this together, I like to think of it as supply and demand. So our supply is that about 1,600 physics PhDs are going into the job market, 300 physics masters, 4,250 physics bachelors, and these are all people that are entering the workforce, right? So that's our supply. What about the demand? What is the demand? And where is the demand? That is more important. Where are these people going? So let's take a look. So what are physics PhDs doing? So earlier we talked about the 2015 to 2016 graduate class, and we said there were about 1,600 that remained in the US. So what we see is about half of these go into postdoc positions, and the rest go into other temporary positions or potentially permanent positions. And what I want to point out to you is that about half of physics PhDs are initially employed in the academic sector. So whether that's some other temporary position or whether they're going and working as postdocs at universities. So half of these initial physics PhDs go into academic positions. However, the other thing I want to point out, a big takeaway from this slide, is that most of the jobs that are potentially permanent, so as we all know, postdocs are by definition temporary positions. So most of the jobs that these PhD holders get that are potentially permanent positions are in the private sector. So 73% of these potentially permanent jobs are in the private sector. Okay, that was 1 year down the road. So now if we look at 1 to 4 years, this is data from the NSF survey of doctoral recipients between 2001 and 2013. So 1 to 4 years after receiving their degree, we still see sort of a 50-50 breakdown between the academic sector and the industry and government sector. 5 to 9 years down the road, we start seeing a shift. And then when you look at 10 to 14 years and 15 plus years, you see a slightly larger shift, and you see that a majority of people, a majority of PhD holders are working in industry or government, and less than 50% are working in academia, whether that's four-year colleges or two-year and pre-college institutions. Okay. So what about masters? That was PhDs, right? Employer distribution of exiting masters 1 year after getting their degree for classes of 2012, 2013, 2014 combined shows that there are many different places physics masters end up. Of the majority of the physics master students, they also go into the private sector. And I'm not showing this data here, but only about 19% find jobs in academia. And the reason I showed this plot, the reason I like this chart is because I like to show people it's a common myth that you can't get a job with the physics masters, or there isn't much demand, or you have to have a PhD to do research or do the job that you want to do. And that's completely false. As you can see, a physics master's opens doors to a variety of different career paths. You can still get a lot of engineering jobs. You can still do physics and astronomy, and about 25% of people go into computer and IT. So even with a physics master's, you can do many things with your career and still have an engaging job. Again, working off the same myth that physics masters or PhDs don't get to do what they want to do if they go into industry, if they leave academia, that they don't get to do research. That is a common myth. However, if you look at data, again, whether it's the finance sector, whether you're working as a government contractor, or if you're working in various jobs in industry, whether that's engineering or computer science, research shows that most of these PhDs and masters getting jobs in these sectors are doing research. So what are the answer to the question, what are they doing, is performing research. The difference may be between academia and industry. The difference may be that they don't have as much say in what type of research they get to do, but they do get to do research. So you will use your physics training, your research training, even if you don't go into academia for your job after your degree. Okay, what about bachelors? What are they doing? So of 8,800 recent degree recipients between 2017 and 2018, what we see is about half continue their studies in astronomy or physics or other fields. So they go into graduate education. And the other half, 52%, go straight into the workforce. So that is another myth, that you have to have a higher degree in order to get a job, and that's completely not true. I also like to show this to faculty members in the audience, that 50%, 52% of your students in your undergraduate courses will go straight into the workforce. Okay, and what type of jobs are they doing? A majority of them work in STEM or related fields. So whether that's engineering, computer, IT, other STEM, a few of them still do non-STEM jobs, but those jobs still require technical training, solving technical problems. So no matter where you end up, you can still find a job in industry where you are using your training. Okay, so we talked about where these people are going. We also talked about what our supply is. Now let's look at the specific demands of specific sectors, right? So looking at the academic sector, this graph right here shows the number of tenured and tenured track positions, faculty hired by physics departments over recent years. And what I like to point out here is, if you look at 2016 data, there were about 300 new hires for tenure and tenure track positions at physics departments. And I want you to recall that about 1,600 PhDs are looking for jobs every year. There's about 1,600 physics PhDs being produced and looking for jobs in the US, while about 300 tenure and tenure track positions open up. I also want to point out that this number is increasing, but there's still a very large gap between the demand and the supply. I do want to point out that this plot shows tenure and tenure track positions only, but if you look at all types of faculty positions, about 20% of them are temporary or non-tenure track. So two caveats here. So one, this plot doesn't show the whole story, right? There are other positions that you can get that aren't tenure track. But the other caveat is that it's possible that these people who are in the temporary or non-tenure track positions are also applying for these positions, right? For the tenure and tenure track positions. So it's not just the recent 1,600 PhDs. Okay, so that sort of shows us the academic sector demand. It's there, it's not high. It definitely does not match the number of degree recipients that we are producing. Next, industry demand. So earlier we saw that from the NSF data that 10 to 14 years later, 15 years later, people are switching, or more and more people are going into industry or government jobs. I want to show that this is, so while I showed data for 2001 to 2013, I want to let you know that that's not anything new. Industry really has been the largest employment base for physics PhDs for decades. This has been the case for decades. I think people are becoming more and more aware of this now. I apologize if this is something you already know. We'll get into new stuff soon, I promise. So this is the industry demand. There is demand in industry for physics PhDs and masters and all degree holders. I want to talk a little bit about why that demand is there. So there was a survey conducted by Kettering University a few years ago. And what they found is that employers in STEM fields value physics graduates in their companies as members of interdisciplinary teams. So this is sort of the feel-good slide for all of you, all the students and early career scientists in the audience. You have a lot of skills and you are greatly valued, and there is a demand for you in industry. Over 80% of the surveyed employers agreed that physics majors could easily grasp new knowledge and concepts, that they were able to identify, formulate, and solve problems, that we are able to successfully analyze and interpret data, and we can engage in continued learning and problem solving. So that is a big skill that the physics training gives to us, is that not only do we come in with knowledge and skills, but one of our skills is to continuously learn and build on that knowledge and solve technical problems. So if any of you are working on your resume yet, these are skills that you can write down that you have in your resume, because our physics training definitely provides these for us. On the other hand, STEM employers also say that physics graduates tend to be missing some important training and experience. And I am not showing this slide to discourage anyone. I am showing this so that you can look at which of these you may be missing and which you might want to add, which you might want to work on. Right? So for example, designing a system, component, or process to meet a specific need. So it's very common at a company that you are not just exploring everything about a material, but you're designing a very specific system for a specific need for a customer, right? Working on multidisciplinary teams. So here I think in particle physics, we tend to be a little ahead of the curve. I myself, while working at Fermilab, I got to work with engineers and technicians, got to work with a lot of different people. And so that is an important skill and it's highly valued in industry. So that's something to think about. Another skill that employers say physics graduates are often missing is recognizing the value of diverse relationships. So for example, customers versus supervisors, leadership skills, and lastly, but very important, communication skills. So I don't know about you, I went into physics in undergrad because I hated writing, and I did not think I was a very good communicator at the time, but these skills are very important. And I will also say that these aren't just important for industry. I know this slide is about industry employers, but I'm sure if you ask faculty members around you, both oral and written skills are very important in academia as well, right? You have to write grants, you have to talk to funding agencies and be able to explain why what you're doing is important. So this skill, especially tailoring your message to specific audiences, is very important. And then, yeah, lastly, real world experience in companies before graduation. So once again, the point of this slide is to not to make anyone feel bad, but to give you a list of skills that employers are seeking and think are important. And possibly these are things that you can work on, right? Maybe you can pick up a project where you're designing a specific system, or you pick up a mini project that's related to your research and lead it, and lead a team of people working on it, right? Communication skills, ask if you can help write a grant, work on a paper with someone, practice, go do some outreach, right? These are all things that we can work on and get better at and then add to our resumes. Okay, so far, bottom line is that the majority of physics degree holders at all levels find jobs in industry. And the good news is that the private sector has a very high demand for physics degree holders. And sort of the less good, but still good news, is that there are some things you can do to better prepare for your career. So now we're going to switch gears a little bit and talk about what these things are that you can start doing to prepare. So the first thing I always start with is look inwards, reflect, and think about what you want. So the very first step of career exploration is to perform a detailed self-assessment. And this includes what you are good at. So write down the things that you excel at, what your skills are. But I always say that it's also important to write down what you enjoy doing. So I don't know how many of your mentors have asked you what you like, what you're interested in, what your goals are, but your values are important. So think about what your values are and what you enjoy doing. Think about where you want to be in a year, in 5 years, right? Those things are important. This is your career. Keep a career journal. I know it just sounds like one more thing to do, but I promise you it is helpful, and it will come in handy and help you in the future. So track any insights you have. So while you're, I'm going to say lab, but while you're working in your office, wherever it is that you're working, track insights. What was something that you enjoyed? What was something that you did not enjoy doing, right? Track any contacts that you're making. So say you met someone at a conference, remember, write that down and write down what it is that you learned about them and their career. These will all come in handy. And then again, what is important to you? Is it work-life balance, money, location of where you're working and where you're living? If those resonate with you, then industry might be a great fit for you. Or if you think having a flexible schedule is more important, having control over your research more important, then academia is better fit for you, right? But it's important to write down, to learn what it is that you care about more. And it's okay for those things to change. That's why we keep a career journal and update it. Document your skills. So of course, record all your technical skills that you learned how to program a new language, or you picked up some soldering skills, right? So write down all your technical skills, but also write down your non-technical skills. Did you lead a project? Did you mentor an undergraduate student, right? If you did that, if you conducted an outreach activity, those are also skills, and they're highly valued, as we saw, by industry members. And once you start documenting these now, what you'll see is when you're ready to apply for a job and you're ready to build that resume, these will be the building blocks. So you'll already have a list of things to add to your resume. You would have done half the work already, right? Additionally, if you start recording your skills now, that'll give you a great opportunity to identify missing skills, right? I gave you a list of skills that employers look for. So maybe you can look there and say, okay, I'm pretty good at these things, but here are things I can improve on. And then you can make a plan for acquiring them. Right now, during this COVID era where we're all teleworking, it's a great time if you do have time and you have the mental capacity for it. It's a great time to pick up a course or pick up a small project and improve some of these skills, right? Okay, what else can you do? Use resources. Specifically, I would say you should use APS resources. So on our website, we have an online professional guidebook. And what that does is it gives detailed advice on key aspects of career development. So it basically starts with self-assessment, like what we just talked about, and then it goes into networking, interviewing, negotiation strategies, and more. And for each topic, there's a 5-minute webinar clip we have a large archive of careers webinars. And in the professional guidebook, what we've done is we've taken 5 minutes from each relevant webinar and sort of placed them by these topics. So you can really just go through the professional guidebook and start developing your career. What else do we have on our website? We have a job board. So you can actually start browsing the physics job board and see what companies are posting jobs. I would even say, even if you're not looking for a job, I would recommend checking it out and just checking out job postings, because job postings include what skills companies are looking for, and they include descriptions of jobs. And those can be very useful to think about as you're making this career journal, right? What are skills, like, does this job sound interesting to you? And what skills does it require? And do you have those skills, right? Next, we have, this is one of my favorite resources that we have on our website. We have physicist profiles. So we have profiles of over 50 physicists in their different career tracks. So you'll see someone who has a bachelor's in physics and is now a consultant for a business and technology company, right? We have someone who has a master's in physics and now does outreach full-time. We have someone who has a physics PhD and they're now a data scientist at a company. So I highly recommend checking out these physicist profiles, because it gives you an idea of many different career paths that people take. We also have common career paths listed on our website. So those are sort of consolidated profiles of the different people for the most common career paths. So we have a page on data science. The page highlights what training you need in addition to your degree in order to do a job. What does a normal day look like for a data scientist working at a company? Sort of what things they do throughout the day, what skills do they use, right? So both of these are very valuable resources. They're completely free. You can just go on our website and start browsing them right now. And also we have a professional development webinar series that's coming this summer. Actually, we have our first one scheduled for next Wednesday. So if you go to our website, we'll be posting all information and updates on there about these webinars. And I hope you'll be able to join us for some of them. Okay, what else can you do to start preparing if you haven't had enough yet? Expand your career contacts. So start building your network. Right now, even when people aren't holding in-person conferences, there's still a lot you can do. So you can join LinkedIn. If you don't have a LinkedIn, I highly recommend you get one. Even if you go on there and just add 10 people right now and then don't look at it for a year, what happens is those 10 people are going to connect with more people. And when you come back in a year, there will be 100 people in your network or more, because those 10 people have made more contacts and now their contacts are also in your network. So your network grows automatically. So I highly recommend making a LinkedIn page. Attend events. So I know that not a lot of mixers are happening right now, but y'all are here. Thank you for being here. But keep attending such events and talk to people, reach out to people. If you found someone's talk interesting, reach out to them and connect with them. If there's someone that you meet whose job you really like and you think you might be interested in, offer to volunteer your time for them. Ask them if there's something they might need help with. That is a great way to build a relationship and show someone that you're interested. Of course, only do this if you have time, but it is definitely a great way to start. Another way to build your network is through the APS Impact Program. So this program is specifically designed to connect graduate students to industry mentors. Graduate students and early career scientists to industry mentors. So if you sign up as a mentee, you can go and connect with an industry mentor. You can browse through our listing of people who have said that they're interested in mentoring students and early career scientists, and you can connect with them and start chatting with them. And also, this isn't the only place, right? So find several types of career mentors. What I like to, how I like to think of it is that some mentors will be your advocates. So these are people who know you personally, they're a sounding board and a mentor. So these people are likely your family or friend. Some mentors are connectors. So these are people who have a professional network. These are people who have other professional contacts and they are willing to connect to you. So this could be your advisor because they have students who have moved on, right, and have jobs, so they can connect you to alumni. Or maybe you have access to alumni who have graduated from your program. So look for connectors as well. And then there are mentors who are experts. These are people who have experience in a specific industry and they can give you advice relevant to their specific area. Okay, if you're not sure how to do this, how to build your network, how to connect to people, a really great tool is what's called an informational interview. So what an informational interview is it's basically a 20-minute phone chat or a video chat. All it is a conversation. This is where you get to ask the questions. So if there is someone you met who you think has an interesting job, or if it's someone where you don't know what their job is at all, ask them for a 20-minute chat. Most people love talking about themselves. And if you're not asking for a job, I do not recommend asking for a job. If you're only asking about their lives and their jobs, most people are more than happy to talk to you. So ask about their career path, ask about their typical work day, ask about, what parts of your job do you like? What parts of your job do you not like? And then if you are interested, ask how you can get involved, offer up that volunteer time, right? Informational interviews are an extremely valuable tool. I did a few of these at least over the last 2 years before I graduated, and definitely I found my current job through doing one of these and getting involved and volunteering my time. So these work. If you are a little nervous to reach out to people and talk to them or meet them at conferences, it might help to develop a pitch. So this is just a short introduction to yourself, maybe 30 seconds to 1 minute, so that when you go up to someone, you already know what you are going to say. Make sure to make it a conversation. Don't list facts. Most people appreciate connecting with you. So make it a conversation. If you want some help in preparing this, you can use the present, past, and future format. So maybe start with, hi, I am your name. I've worked on, this is what my research is on. I'm looking for opportunities to do da 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 da. So that is usually a good format that gets across who you are and what you're interested in. And then be prepared to answer questions. So you never know who you'll meet and what they would want to know. So they might ask you why you're passionate about a specific industry, right? A specific career, or why you want to learn more about it, or why you feel you're good at something. So be prepared as you are meeting new people and developing your network. Okay, so that's a lot of things that students and early career scientists can do. I also have just a couple slides on what faculty and mentors can do. So like I said, most of your students are going into industry careers. So there's a lot you can do to help them prepare for that. You can start by inviting speakers from the private sector, from national labs, to come to give talks and talk about their careers at your institution. Normalize industrial careers. A lot of the times, all we hear during undergrad or grad school is the academic track, but about 50% or more of degree holders go into industrial careers. So just normalize that. So there's less of a stigma about it, right? That can be a huge help. Encourage more industry contact and mentorship. So again, tell your students about the impact program. And also Faculty should also make their LinkedIn pages and connect with their students now. So if you connect with your students now, and once they graduate and go on into different careers, you'll be connected with industrial physicists in the future, right? So I highly recommend doing this now. Another thing that you can do, should I be looking at this chat? Oh, okay, sorry. Another thing that you can do is evolve your physics teaching to incorporate more workforce relevant experiences and knowledge. So think about the experiences, the courses, and the research opportunities that your students are encountering that explicitly connect physics concepts with real world applications. You can utilize physics principles to create innovative solutions to real world problems. And that's a big skill that your students should be learning, right? You can include content relevant to careers in the private sector, such as communicating to audiences, intellectual property, teach your students about private and public funding sources, what business models look like, how to budget. And honestly, again, I say that these are for careers in the private sector, but all of these are useful for academic paths as well, right? Budgeting, writing grants, public funding sources, all of these are useful for whatever career your students will have. So try to incorporate these ideas into your teaching. If you're not sure where to start, we have what is called the APS Pipeline Program. This is my boss's program, Crystal Bailey, who's the head of careers at APS. This program was started because it was advised by experts from established physics entrepreneurship programs. And the goal of the program is to develop curricula, best practices, and research instruments for teaching physics innovation and entrepreneurship to undergraduate and graduate students. So the approaches, there are several different approaches under development. I'm not an expert on this, but I'll just give you a few examples. So how to utilize experiential learning and maker spaces. There are examples of courses online on communication, intellectual property, business structures. So if you are looking to incorporate these things into your courses, please go on this website. There are courses on there. There's materials on there that you can immediately get your hands on and start using in your classes. Again, the summer and this telework is a great time to maybe reflect on some of your courses and what you're teaching your students, and how to incorporate skills that they will be using, how to incorporate knowledge that will get them the skills that they'll be using in whatever career they choose to go to. Okay, I'm getting pretty tired of talking, so I will end here. The summary is that many physics degree holders enter the job market every year. A majority of them find careers in the private sector, and you can start preparing now by expanding your network, both students and faculty, and using APS resources. All right, thank you. I will now take questions or comments. Oops.
Yeah,
thank you very much,
Midhat.
So now we have some time for questions. So there's two ways that you could ask questions. One would be to raise your hand in the chat window. The other is just to type your question into the chat box. And we can try both ways. So if you have any questions, please go ahead and raise your hand.
The raise hand is the participant, not in the chat.
In the participants, sorry. In the meantime, just before we take any questions directly, I already have received one question from an anonymous participant, and maybe I can start with that. So the question is, could you say a little bit about the current pandemic situation and how that might change the employment situation for PhD, master's, and bachelor's recipients? For instance, many universities have instituted hiring freezes and are anticipating very difficult times ahead. This could impact the ability of postdocs, especially senior ones who might be trying to move into a faculty position. Also, there appears to be a drop in there could be a drop in the undergraduate population in the next few years. If you have any comments on this very difficult, broad topic, that would be very helpful.
Yeah, so I just gave another talk last week, and this was definitely one of the first questions. So yeah, these are uncertain times. I think we're all trying to do the best we can. I've heard about the university freezes. I'm not sure how much companies are hiring either. I know that we have still gotten a few job postings on our job board, so it's not that no one is hiring. There still are people that are hiring, and there are various resources you can look at to see. I think there are some resources on LinkedIn, and I believe our forum on early career physicists is coming up with a list of resources where jobs are still being posted. The APS job board is definitely one of them. It is hard for me to predict what's going to happen. It's hard for any of us to predict what's going to happen. APS is working on, we have an Office of Government Affairs. We're working on urging all funding agencies to continue funding grants, continue extending grants after, because of issues that have come up, issues that have come up and have slowed down research. So to extend grants and deadlines so people can be funded even after the pandemic is over and people get back to work, so they have extra time to complete their research. But that's all I really have. I don't have that much power, so I can't predict how things will go. But I will say that I think mental health is very important. So I think it's important to take time for yourself. It's important to try to keep positive. It's okay if, you know, they're not good days. But it is definitely, for the days that you do have the strength, it is a really good time to work on your skills, look at your resume, start networking. I've actually been doing that, where there have been people that I've been meaning to connect to for a long time. So I'm just trying to shoot out emails and ask people to talk. You can still learn a lot about different industries. You can talk to specific people in different industries and ask if their company is still hiring or how their company is managing the pandemic, right? If people are still getting paid, if they're able to telework, that this might be a great time to learn about the culture at different companies.
Thank you. Maybe I could just, since we have Keith Denis, who is a program manager at the NSF, maybe I could just ask if he might have anything to add very specific to the field of particle physics in terms of how the pandemic might impact our field over the next period of time, if you'd be willing.
Yeah, so hi. I really can't speak on behalf of the agency, but I know that our regular programs are continuing. Our budgets have not changed because of the pandemic. There are extra pots of money that are now available within the National Science Foundation for COVID-related research. And so we encourage people, and we can issue grants through certain special programs rather quickly in order, using some of those monies to fund COVID-related research, but that may not impact high energy physics a lot. But as far as the grants, the speaker just pointed out, very nice talk, by the way. Speaker just pointed out that the issue might be that the grants need to have some regular grants need to still have some flexibility because of the COVID situations. And I can say that the agencies are well aware of this, and we program directors are, for example, authorized to give a lot of flexibility because of the special COVID situation. So anyone whose research progress has been interrupted or impacted by COVID, if you're a student or a postdoc, feel free to talk to your supervisor, the one who usually is the PI on the grant, and tell them that they should contact the program director or who oversees their grant to learn about all the unusual ways in which certain rules have been made more flexible in order to help with the situation. The agencies are here to help everything move as smoothly as possible.
Thank you, Keith. Okay,
we have a question in the chat from Prasant. He said, you mentioned normalizing non-academic jobs, especially with regard to student training. Do you have any thoughts on how such a change can come about?
Yeah, so I'm going to go back to this slide real quick. I hope everyone can see it. So definitely a lot of this happens, a lot of the culture in the department is set by the faculty and by the administrators in the department, right? So having a continuous series. So for example, at University of Michigan, we had a series of seminars that were specifically for life after graduate school, and we had almost weekly, not quite, but almost weekly, we had alumni who would come in and give talks about their careers. And to me, that was so important because that was almost the only exposure I ever got to jobs outside of academia, right? So that's one way to normalize it, is to have a semi-regular series of seminars or talks. Or, you know, if you can't do a weekly seminar series, maybe you can do 2 talks a semester or 2 panels a semester, right? So that is really important. Another thing I didn't mention is I would encourage faculty members and also grad students to talk to your students early on about career development. You know, have them, ask them to go through these steps of self-assessment and think about what their values are. Ask them what's important to them. And also this one, people don't always receive well, but encourage internships. Encourage your students to get internships over the summer. You know, research at the institution is very important. REUs are very important, but maybe for one summer, a student goes and gets an internship at a company. And if that becomes normal, if that becomes regular and a lot of students are doing it, then you start to see more of a culture where industry careers are common and well known.
Thank you. There are more questions coming in the chat. Daniel Gift is asking, are there resources for finding out what jobs require or benefit from a physics bachelor's versus master's versus PhD? To know what jobs are perhaps more suited for, say, someone with a PhD student versus just a bachelor's.
Yeah, so I mentioned these various resources we have on our website. So one thing you can do is go to the APS job board or go to any other website that posts jobs and look at what degree levels the jobs are requiring, and then look at what skills they're requiring. And you'll begin to see a correlation, right? You'll see that, okay, this job requires a bachelor's degree minimum, and here's some of the skills they're looking for. And so you will know that, okay, if I am getting a bachelor's, I should have some of these skills before I go into the job market. Similar for different degrees. Sometimes jobs will say bachelor's required, master's preferred or recommended, right? So you can definitely do that research by yourself and look for this information by browsing job postings. But the other one I would like to highlight is this if you go on aps.org/careers and you go to common career paths, we basically have, so I did talk about this in my talk, but I'll repeat it since this was asked. We have a page on a consultant career, or a physicist career as a data scientist, or a physicist career as a faculty at a liberal arts institution versus a research institution, or how to get a job, not how to get a job, but working at a national lab with a bachelor's versus a PhD. So we have those resources, and they list different trainings and skills that you need in addition to your degree to get to those jobs and get those jobs. And also on those pages, we have listed a few physicist profiles who have done that, who are in those careers. So you can always read about people's careers and their career paths to see what someone did to get to the point where they are now.
So we have another question in the chat from Marvin Flores. You mentioned that majority of students end up in the private sector. Are there existing statistics regarding how many of these would have preferred to stay in academia? He has an anecdote which says he personally knows people who are in industries but would have loved to continue doing physics. Similar question, but vice versa. Are people in academia who would have preferred a chance to go into the private sector? And he says, thanks for the awesome talk.
Yeah. Thank you for that question. It is a loaded question. There are a lot of aspects of it. So I do want to start with saying that when you say people who would love to continue doing physics, I think what you mean is continue being in academia, because it's, again, a common myth that you'd no longer do physics if you aren't in academia, if you're in industry, but you'll see that in many jobs, you're still doing physics. You're still using your training, you're still doing research. So I try to avoid saying continue doing physics versus academia or versus industry, right? And then to answer the other part of your question, it is really hard to figure out, to survey this, to get a complete picture. You would have to survey every single physicist out there and ask what job they're in. Do they wish they weren't in this job? Do they wish they had stayed in academia, or ask academics if they wish they had gone into industry? So that is hard. That is a hard survey to conduct, especially because people's priorities change. How they're feeling might change on a day-to-day basis. But I believe there is, if you go on aip.org/statistics, they do have some data on postdocs. So research does show that most people who go into academic postdocs go with the intention of pursuing academia. And that doesn't always happen. Sometimes it does, sometimes it doesn't. I will also add that while I try to tell everyone that, you know, industry is the larger employer, more people go into industry than academia, I'm not here to discourage anyone from pursuing what they want. I just want you all to have all of the data, all of the information, and make the best decision for yourself. Because when I was a second or third year, all I heard about was academic careers. And that's what I thought I was supposed to want. But really getting that exposure to other careers helped me realize that that wasn't even what I wanted. You know, so it's not that I left academia because I had to. I left it because I was really excited about my current job. I hope that answers most of the question.
Yeah, anytime, you know, if your question comes up and you want to put something more for clarification, just unmute yourself and you know, chime in. We have a comment in the chat from Chris Krylova. I hope I didn't butcher your name too badly. As a person who has been in the industry sector for a few years now, I would have to add that interview skills are very important in addition to a fluid resume. I'm not sure if APS has resources for that, but that is vital to a success of anyone going into the industry sector.
Yeah, thank you so much for adding that. Absolutely. So we have this online professional guidebook where we give overviews of topics like self-assessment networking, and interviewing is definitely one of those topics. We also have a little webinet that goes with that topic, but you can also watch the full webinar on interviewing and negotiation. I will add negotiation is also very important. And when you do think about negotiation, often people think that it's just about a salary, but there are many things to consider when you are negotiating an offer. For example, healthcare benefits, or how many vacation days you get, right? Or how many days do you get to telework? So those can all fall under negotiation, because sometimes there isn't much room on the salary front, but then you can leverage these other benefits that are more important to you while negotiating. Also, we are, like I said, we're working on this new professional development webinar series, and we're still developing it. We have 2 or 3 planned right now, and we're working on what to hold next. So I'll make a mental note of that, and maybe we'll do one on interviewing.
There's a question from, sorry if I say this incorrectly, Alejo Rosia. I understand that the percentage of people who go to industry at different stages doesn't distinguish among areas of physics. How does this picture change when restricted to high energy, experimental plus theoretical, or separate? Do you have any idea of the situation in other continents? And thanks for the talk.
Yeah, so I don't know much about other continents. I'll try to restrict this to US, but one thing that physicists often do, one thing we're taught to do in academia, and I did as well, was have this physics identity associated with the sector of research that you're in, right? So I was like, I'm a particle physicist, or I'm an AMO physicist because I work on magnetic fields. So that is not how it is viewed in industry. When you are going into industry, you have to switch. This is how my boss always says it. You have to switch your basis. You have to rotate your basis vectors. So instead of thinking of yourself as a particle physicist or a nuclear physicist or a condensed matter physicist, you should think about yourself as someone with a specific set of skills, because that's what industry, that's what companies are looking for. They're not going to say, I am looking for a particle physicist. They're going to say, I am looking for someone with these specific skills. Having said that, it is true that you might get certain skills in if you're doing one type of research versus another type of research. For example, if you're a theorist, you're probably not going to learn how to, machine shop things. You're not going to have that skill, right? So it is true that as someone who is a theorist or someone who's in particle physics, what I've seen is those people tend to go into data science type of jobs. But that's not, I don't want to, I'm giving an example, but I don't want to limit what you can do. So again, I would say start doing informational interviews, look at what alumni are doing, reach out to different people and see what kind of careers they're going into. Even if you're not super interested, you never know what you'll learn, right? Maybe you'll learn that it's something you don't want to do. When I was in my third or fourth year, I did an informational interview with someone who worked at an insurance company, and she did data modeling for an insurance company after getting her PhD in particle physics. And I was not at all interested in doing that, but I talked to her anyway to learn what she does. And I ended up telling friends about it, right? And helping them connect to her. And also she connected me to my current boss. So you never know. So again, sorry, I know I've kind of wavered away from the question, but do informational interviews. That is the best way to find out what careers are out there.
Okay, there's another question from Marvin Flores. Thanks for the detailed answer to my question above. To follow up, at what age would you say is it too late to do a career shift? For example, if you're in academia, then decide to go to industry, or the other way around? Or is it ever too late?
Yeah, so I am an optimist, and I would say it's never too late and you can do it anytime. I would encourage you to do what feels right for you whenever that is. But I will say that industries, if you have had a couple postdocs after graduate school, industries see that as they see that, oh, maybe you were trying to pursue academia and that didn't work out and this is your second choice. So they do see it that way. So I would encourage you to make that choice earlier rather than later. I don't want to pressure anyone, but it is better if you decide sooner what you want.
Having said that, though, if I may add, I personally know some people who were already at a junior faculty stage when they went to industry. So it is possible they might have done, some legwork in cultivating the new position. I'm not aware exactly how they did it, but it's definitely possible.
Yeah, absolutely. And whenever you are if you choose to do this, just be honest. Be honest that, this is why I'm doing it. I've realized that my priorities and my life needs are not being met with this position. I'd rather do something that's more in an industry setting. That would be my advice.
There's a question from Itai Block. He asks, are there industry jobs that do work in particle physics?
Yeah, and I like Chris's answer to this. Industry sells a product. There is nothing you can sell in particle physics. Well, I don't know if there's nothing you can sell. You can definitely sell ideas. But the programming and data science skills of particle physicists are useful in almost every sector these days, from finance, IT, etc. I completely agree with that.
Itai is not happy.
one can probably never rule it out. I think there are probably, you know, some detectors that were developed for particle physics that are actually used in industry. But the number of jobs that would be like that would be very few and extremely hard to find. So, you know, if you find one of those, great, but you should not necessarily make a career plan around these kinds of things.
Yeah, if you specifically set out to look for particle physics jobs, you'll only be limiting yourself. So I would definitely say expand your search and talk to people at the company, talk to them about what their current job is like. I'm sure you'll be able to find something that'll make you happy. And could be, so the person I was mentioning earlier, the person who did data modeling for the insurance company, she told me that it was, I quote, eerie how similar her work was to what she used to do as a student. Like some of the models that she used and the programming language she used and the program she was writing, they were so similar to what she was doing in grad school that it was kind of freaky. So I definitely encourage you to look at a broad set of career options, and you never know what will make you happy, even if it doesn't have the label of particle physics on it.
Okay, so it's 2:00 right now. Midhat, do you have any sort of final parting words to give everyone?
Just thank you so much for attending. It was a great turnout. Feel free to reach out to me. My email's right there. I'm happy to provide more resources or answer questions.
Okay.
Yeah, and thanks to you for making yourself available. And I think this was very nice.
Yeah, very nice overview. Okay, so we'll close the session, and the parallel sessions will start in about 15 minutes. And again, you can find the links to that on the schedule with the full Zoom links. So we'll see you in the parallel sessions. Bye, everyone. Thanks again, Midhat.